Exercise 3.10. Show that the following series converges and find the sum to infinity. Okay, looks like another partial fractions job. So let's take care of this. So 2 divided by r plus 2 times r plus 4 is equal to a divided by r plus 2 plus b divided by r plus 4 if and only if 2 is equal to a times r plus 4 plus b times r plus 2, if and only if, well, not only if, it does imply though that 2 is equal to positive 2a, so that means that a is equal to 1, and also that 2 is equal to negative 2b. So that means that b is equal to negative 1. And so we are looking for the sum from r equals 1 to n of 1 divided by r plus 2 and then minus 1 divided by r plus 4. And I've left a gap because this is the perfect opportunity for us to do our little trick. Minus 1 minus r plus 3 and then plus 1 divided by r plus 3. Did I say 1 minus r plus 3? I meant 1 divided by r plus 3, obviously. Okay, and so then that is equal to the sum from r equals 1 to n of 1 divided by r plus 2 minus 1 divided by r plus 3 plus the sum from r equals 1 to n of 1 divided by r plus 3 minus 1 divided by r minus 4, just by the distributive property of the summation. Okay, and then we know that this is clearly going to just be equal to, you put 1 in here and then you put n minus 1 in here. So that is going to be 1 divided by 3 and then minus 1 divided by n plus 3. So that's the first one. Plus, and then again we put 1 in here and then we put n plus 1 in here and then we subtract. So that would be 1 over 4 and then minus 1 over n plus 1 plus 3 is n plus 4. And a third plus a quarter, what is that? 4 over 12 plus 3 over 12, so that will be 7 over 12 minus 1 over n plus 3 minus 1 over n plus 4. And if we wanted to, we could combine it into a single fraction, but all we need to do is show that it converges. And this one converges because this is the sum from r equals 1 to n. So this thing here is the sum from r equals 1 to n. And so if we let n tend to infinity, so it converges because as n tends to infinity, we have this sum here, which was that thing there, 2 divided by r plus times r plus 4. This sum here, let's just call it g of n. We have that g of n, which is equal to 7 over 12 minus 1 over n plus 3 minus 1 over n plus 4. We know that g of n tends towards 7 over 12 because as n tends to infinity, this thing tends towards 0 and this thing tends towards 0. So the whole thing tends towards 7 over 12. So that means the bigger we make n, the more of these terms we add on, the closer and closer we get to 7 over 12. By the way, that's what sum to infinity means. By the way, it means the limit as n tends to infinity of g of n, which was the limit as n tends to infinity of the sum from r equals 1 to n of f of r. So yeah, we showed that it converges, and we found that the sum to infinity was equal to 7 over 12. Alright, next up, exercise 3.11. Show the following series converges and find the sum to infinity. I'm going to be real lazy here, and I'm just going to let you verify that g of n, the partial sum at n, which is of r minus 1 divided by r plus 1 times r plus 2 times r plus 3, is equal to 1 over 6 plus 1 divided by n plus 2 minus 2 divided by n plus 3. So I'm going to let you verify that and then immediately say that the sum to infinity is just 1 over 6. And it converges because the limit as n tends to infinity of g of n is equal to 1 over 6. Because as n tends to infinity, that tends towards 0, and that tends towards 0. So the whole thing converges, and the sum to infinity is 1 over 6.